Hey y'all, hope you're doing well today. Just wanted to make a quick help video to talk about some of the Delta Math problems, specifically the last three that are on your assignment for Delta Math Week 10. And so right now we're looking at sketching graphs from a sign chart. Okay, so here's the idea with these last three problems. And you'll notice, and this will make sense if you read your email, that I deleted one of the problems. So really, the last three problems are just about working with this thing called a sign chart. Really, all that it is, this is a tool for helping us visualize the graph of a polynomial function. Because here's the deal with polynomial graphs, right? We know based on what we talked about Tuesday that it's pretty easy for us to figure out the end behavior. You know, we can figure out what's going on the left end and the right end of the function, whether the arrows point in the same direction or whether they point in opposite directions based on whether the degree is even or odd, right? But the truth about polynomials is that there can often be a lot of complexity in between the left and the right end, right? So for example, we have a number oftentimes of what we call turning points, right? Which is where basically we get some squiggles in the graph, like it changes directions. We have what we call relative maximums and relative minimums, which in other words are just kind of like little hills, little valleys in the function's graph, right? There's not really a good rule for helping us memorize that. Instead, we rely on this thing called a sign chart. And really, all that a sign chart is, it's a way of describing the behavior of the function in the simplest possible terms in reference to the x-intercepts of the function. Okay? So in other words, if we know the x-intercepts of the function, we know the only places where that function is going to cross the x-axis. Which means that if we want to visualize the picture, all we need to know is what's happening between those x-intercepts and outside of them. And when I say what's happening, what I really mean is whether the function is above or below the x-axis, right? That's really all that we want to find out. So if we know where the function touches the x-axis, and if we know where it is above or below the x-axis, right, between those points, we can get a pretty good idea of what the picture looks like. Okay? The way we represent being above or below the x-axis is by describing the function as positive or negative, right? So if we say that the function is somewhere up here, meaning above the x-axis, we say that it's positive. If we say that the function is somewhere down here for a certain interval, we say that the function is negative at that point. Okay? Sign chart tells us exactly where the function crosses the x-axis and where it is in either of those regions. Okay, so let's take a look at the sign chart, right? And you'll notice the sign chart really just gives us the x-axis, right? It's kind of just a way of visualizing, again, where does our function cross the x-axis? And so we see that the x-intercepts are all going to be the points labeled on the x-axis on our sign chart. So in other words, this tells us that this function has 4 x-intercepts, one at -1, 0, another at +1, 0, another at +3, 0, and then a fourth one at +6, 0. Okay, so here's the first thing that we need to know. Our graph needs to hit each one of those points on the x-axis, right? So no matter what else the picture looks like, we know it's going to touch the x-axis here, there, and there. The only other thing we need to do, is figure out what it looks like around those points. And again, all that we're looking at is the sign, right? So for example, we notice that if we are left of our first x-intercept, the sign chart tells us the function is negative, meaning below the x-axis. So in other words, if we're left of this first x-intercept, we know we are down on the negative side of the x-axis. That's our first piece of the function. Okay, let's move on to our second zone. So now if we are to the right of that first intercept, but still between that and our second, the function is positive. If it goes from negative to positive, that means the function is going to cross the x-axis. But ultimately, it has to come back down so that it hits that next x-intercept. So it goes up a little bit, but it has to come back down, right? We'll finish up with the rest of this in the next video.